So here's the deal today. Those theorems are still going to be in. Those theorems are still going to be in your reasons column, along with alternate interior angles, corresponding angles, same side interior angles. They're all going to be there. Just bring this today because I detached it from your test. All right, so mark your diagram here. I figured the easiest way to start this, because these proofs are going to get harder, the easiest way to start this with you guys was give you all the statements and see if we can write it in the reasons and see how it connects. So I'm telling you A parallel to B. Remind me from yesterday, how do you mark the diagram to show A and B are parallel with what? Arrows. Arrows. Here we go. So A and B are parallel. So are C and D. So you could put double on those if you wanted. C and D are parallel. Statement number 2, I'm saying, hey, why is 3 supplementary to 2? If you know those lines are parallel. Look at angle 3 and 2, everyone. 3 and 2. They're not linear pairs. Can we all agree on that? They're not right next to each other. They're not adjacent. So I can't say linear pairs are supplementary here. But they are a special type of angle from yesterday. From yesterday. 3 and 2 up there. We talked a bunch about those. What type of angles did we call those with parallel lines? They're not linear pairs, so get that out of there. 3 and 2. Look where they are. Okay, look where they are. 3 and 2. Why am I saying they're supplementary? What type of angles are they? Let's start, Juliana.
Same side.
Everyone, same side interior angles. Everyone agree? So if they're same side interior, they have to be supplementary. So reason, we wrote it out all yesterday, and I'm hoping the reason why I did it all yesterday with you, so it's smooth now. Parallel lines imply, this is what we wrote in our notes yesterday. Juliana, back to you. What type of angles are they?
Same side.
Parallel lines imply same side interior angles are, and again, what do we know about them? If they're same side interior, Matt, what do I know about them? Supplementary. And you guys, again, abbreviate it SUPP. Done. So 3 and 2 are supplementary. Look at number 3. Now I'm saying 1 and 2 are. And I want a reason why are 1 and 2 supplementary. They're not linear pairs, right? Hey, that's a linear pair. That's a linear pair. 1 and 2 up here don't look like that, so don't tell me they're linear pairs. Something else. Why are 1 and 2 supplementary? Remember, you got a bunch of parallel lines up there. What type of angles are those? Don't give me something brand new we've never used either. One and 2, what type of angles? You got it. What type of angles are those? Don't take it too far here. Don't take it too far, Jayla. They're still same side interior, aren't they? Same side of the transversal inside these parallel lines. So same reason here. Parallel lines imply same side interior angles are supplementary. Good. Ooh, how are we going to wrap this up now? 1 congruent to 3. And 1 and 3 have no relationship. Don't tell me they're alternate interior. Don't tell me that they have no relationship. We got to go old school here. We got to go old school here. This is where it's going to get tough for you guys. Mixing the new stuff in with all that stuff I showed you in Unit 2. Look at everything you just wrote up there in steps 2 and 3. What'd you know about it? What'd we say about angle 3? Supplementary to 2. What'd we say about angle 1? Oh, wait. So you're telling me 1 and 3 are both supplementary to what? The same angle? We got something on the sheet that says why those 2 angles are going to be congruent then. This isn't going to start out with parallel lines. 3 supplementary to 2, and so is 1. So 1 and 3 are supplementary because what? Theorem from last unit. Here's how we're going to tie it in. Alex? of the same angle, right? Supplements of the same angle are congruent. Yeah.
Why is it not? Oh wait, no, never mind.
Why is it not substitution?
But
Got it. Hey, look, it's got to be right. If I put equal signs here, it's substitution. I can't do substitution with supplementary angles, only equal angles. Remember that. Yep. Supplements of the same angle are congruent. That's where we are now. This is where we are. Parallel lines with all those theorems from last unit. And I held your hand on that one. All right, what if this was just a blank slate now? Ready for number 2? Here's a blank slate. Set up your statements and reasons, put in your givens, mark your diagram, and then we'll have a little fun with the colored pencils. Should have arrows on AD and FB. And also marking CDA congruent to BFE. Hopefully you can identify where those angles are. Does everyone see the angles I need to get congruent? Identify those too. Don't mark them, but make sure you can locate the 2 angles I need congruent here at the end of this proof. CDF looks like a bigger angle, right? And DFE, which looks like a little bigger angle than what I have given. Everyone can see those angles before we start. Grab a colored pencil. Here we go. Grab a colored pencil. I don't know. Look, I don't know if this will work for you or not. Some of you, I'm sure it'll be great. Some of you will be like, this isn't helping me. All right, but I just figured I'd try it out. Take a colored pencil. Highlight the 2 lines that are given parallel. Highlight the 2 lines that are given parallel, please. Put your colored pencil down. Grab a new colored pencil, please. Different color. And what I'd like you to do is highlight the transversal. Can you find a line that connects your 2 parallel lines? See that one in the diagram? Highlight the transversal, aka a line segment that connects the 2 parallel lines. Is everyone highlighting FD? That's your transversal. Everyone's highlighting FD? All right, bad news here. Your days of 2-step proofs are done. All right, they're done. No more proofs are going to be 2 steps. That's done. All right, so this is definitely not a 2-step proof. But what I want you to do right now, you've highlighted the parallel lines and the transversal. Find me a special pair of angles we talked about yesterday. Are there corresponding? Are there alternate interior? Same side interior? There's a special pair up here. But it's got to be with those parallel lines and that transversal only. Talk within your group right now. Can you guys find a special pair of angles for me? And what I mean by special is the alternate interior, the corresponding, same side interior. Can you guys find a special pair of angles that you know are congruent or supplementary? Let's go. Let's go. Can you find it? I need to know if they're congruent or supplementary and why. Look at your highlighted stuff only. Look at your highlighted stuff only. Don't look at the top or the bottom there. Look at what you've highlighted. Okay, any groups confident they found a special pair? This is where we have to do first. I'm given parallel lines. You can highlight them or not. I don't care. But you're given parallel lines. You guys got to find a pair that's congruent or a pair of angles up here that are supplementary. You got to be able to do that first. Using the parallel lines, tell me a pair that's congruent or supplementary. We had any groups confident? Keaton, your group confident? All right, let's go. Where's the pair of angles that you saw?
Angle ADF and angle BFB.
Perfect. Everyone take a look. Angle ADF. See that angle here? Along with DFB. I think Keaton and his group know what type of angles those are, but I'm going to turn it over to the rest of the class. What type of angles did we mark right there? Look at your transversal, where they are. Are they inside, outside? What type of angles did Keating and his group just give us? Those are, Jonathan? Alternate X. Well, be careful. Here are your parallel lines. Right? Are they inside or outside of? Inside. So take that exterior and turn it what? Interior. Alternate interior. Everyone good? And what do we know about alternate interior if I didn't say the word same side? They are congruent. That's why I put congruent marks there. We got to be able to find those. Okay? Got to be able to find those on your own. Let's put that in our step 2. I don't know if some of you see where we're going yet, but so angle ADF is congruent to angle DFB. What am I going to write here now? Everything looks the same, except we name the angles different. Here you go. Start helping us out with the reason. T, you're up. What type of lines did I have? Ready. Parallel lines imply what type of angles? Keep going. Alternate interior angles. What about them? Yep. So if you're given parallel lines, look for special angles right away. All right, now we got to tie this together. Look at your diagram that you marked. How am I going to get those markings to CDF and DFE? Again, look, we got to go old school here. Those aren't, any special type of angles. We got to go old school here. How am I going to do it? How good were we from Unit 2, right? This is where Unit 2 is really going to burn some of you guys. Right, because we never really had a good understanding of it. Take a look at your diagram. How do I go from the angles I've marked congruent to the angles I need congruent? Come on, look at it. Quick, 30 seconds, discuss it with your group. What are we going to do here with the angles we marked to get to the bigger angles there that I need congruent? Woo! We're going to need something from Unit 2 to bring this all together. Okay, here we go. Back together. Any groups confident? What do I need to do? What do I need to do? These two angles to get the bigger one. These two to get the bigger one. What am I going to have to do it? Taylor, you and your group?
Addition.
I'm going to have to add. Yes. But before I add, how many quantities do we always need? 2. How many do we have listed? Let's see. 1 in the givens and the alternate interior. So it looks like I have 2 to go and add together. Good. This is an addition proof. This is addition. All right. Turning back to you guys. Name a pair I got to add then. Look at your diagram. Name a pair I have to add here. Hayden, you're up. Give me one pair. Angle. Good. CDA plus angle ADF is the same as if I added. Here we go. Go on the other side of the diagram now. What other 2 angles do I need to add? Where are we going there? Juliana, go ahead. Angle.
DFB.
Okay, hold on. Yep. DFB plus BFE. Good. And what would you write in the reasons column here? Don't overthink this. There's no parallel lines here, Keating. That's just addition. First time I showed you addition, I promise you, what's always the next step? Yep. I don't care what unit we're in. Questions? Whew. All right, one more. Go ahead, set up whatever you need, mark whatever you need. Okay, if you're ready, grab a colored pencil. Highlight the two parallel lines for me. Grab a colored pencil. Highlight both parallel lines that you hopefully marked already as well. And then see if you can find and highlight with a different color the transversal. Remember what a transversal is. It goes through both parallel lines at one point only. There's only one transversal in that diagram that you should be highlighting. Okay, it's got to go through both parallel lines, just not one. A segment that goes through both parallel lines. Hopefully everyone is highlighting J-E-G-K. J-E-G-K right there. There's your transversal in this diagram. Hopefully we like this because that's our traditional, right, 8-angle diagram that we're hopefully all right with. All right. Anybody's eyes light up when you wrote down a few of those givens? What's up, Matt?
Bisect.
Oh, buddy. Bisects. Not only bisects, how many angles are we bisecting? How many? Two. Anybody know how this one's going to end? If we're bisecting 2 angles, not 1, but 2. Hayden? Halves of equal quantities are equal. That's how it's going to end. Nice. Nice. Yes. It's going to end with halves of equal quantities are equal. From unit 2, what do I need to tell you before I end? Because it's not a 2-step proof. What do I need to tell you first if it's going to end in halves of equal quantities? We always had to have something before. What was that something before we always needed? Keating?
Definition of bisector.
Which was, yeah, that's going to be the reason. But what did you tell me when you wrote definition of bisector?
Is it that like right angles? No, never mind.
Yeah, just good idea. Right angles. Got to tell me what you're taking half of. All right, you got to tell me what you're taking half of. Name an angle you're taking half of. Ready? You guys remember this? Half of. Tell me an angle we're taking half of. Shoom. Hayden, over to you. What are we taking half of? Okay, so everybody, half of JEB. Everyone look at your diagram. Look at JEB. I'm going to take half that angle, but I only want to call it one of those two, though. It's cutting in half. Right? Do I want to call this JEF or FEB? Right? Because I could call it JEF or FEB here, but which one do I want in the proof, right? Which one do I want in the proof, Zoe? FEB? Well, everyone's like, well, how does she know that? It's in the darn proof statement. That's how I know to call it FEB. And name the other angle we're taking half of. We took half of JEB. T, what else are we taking half of? EGD. Good. Look at that angle, EGD. What am I going to call that one now? I have two options, EGH and HGD. So what do I want to call that one? Out of those two, what do I want to call? Oh, T, back to you. HGD, good. It's in the givens. How'd you know we were taking, this is not halves, that's how we're going to end the darn thing. It's not halves of equal quantities. Whew, how do I know I'm taking half of it, Rowan?
Definition of bisector.
Yeah, the word bisector came up. We're not going to end it in step 3, though. This is why these proofs get a little tougher. You're going to use all the givens. We haven't even talked about one of the huge givens up here yet, which is what? We have not talked about what yet? Why in the world did I tell you the lines were parallel if we're never going to use them? You're going to use all the givens every time. So why did I put AB parallel to CD? Because you're still missing something. It's right in front of you right now. How are we going to end this proof again? What's the fact we're going to end it with? Wait, whoa. One at a time here. Ready? Halves of equal quantities. What you're taking half of better be equal to each other. Do we know this? Have we written this yet? That JEB and EGD, the angles we are taking half of, we have not said that they're equal. But look on your diagram. Find those two angles that we're taking half of. Look familiar? From yesterday? JEB and EGD. Tell me something about those angles. What are they called so I can tell you why they're equal? JEB and EGD. What do I know about them? What do I call them from yesterday? Where are we going on that one, Matt? JEB, EGD. Look where they are. This one and that one right there. What did we call those yesterday? Look where they are, Matt. One's where? This one's where? Inside or outside? Inside, outside. Where's this one?
Inside.
Okay, so they're one of each. So we don't have an alternate. We don't have a.
Yeah, I'm trying to think of the word about it.
It begins with a C.
Yeah, I know. I can't.
I'll spot you the corresponding.
Corresponding.
Yeah, there you go, Matt. Good. Corresponding angles. Everyone, yeah, corresponding. And what do I know? What do I know, Matt? Save yourself now about corresponding angles. They're congruent. So that's why I gave you the parallel lines, because whatever you're taking half of needs to be congruent. And when we were in Unit 2, just getting to know each other in the proofs, I always gave you that. But now we had to write it down because of the parallel lines. Reason why they're congruent? Let's finish this up here so you guys can start on your own here. Halo, what type of lines did I have? Here we go. Parallel lines imply what type of angles? CO. I learned my lesson yesterday. 2 R's. Corresponding angles, and what do you know about them? Are congruent. What you're taking half of need to be equal. Is this my last step, though? That's not my proof statement, right? All right, now we're finally done. I know what I'm taking half of are equal, so those halves, FEB and HGD, have to be congruent to each other. That is how we're going to end the proof. Halves of equal quantities are equal. There we go. I guarantee tonight on these proofs, you're going to have parallel lines imply somewhere in your reasons. All right, somewhere in your reasons. So go ahead. If you want to work with the people in your group, fine. If you want to move around and work with people, that's fine. I might be making a bad decision here, but all these proofs are up on Classroom for you to check. If you end up copying, what am I going to do about it, right? I'll give you your 3 points, but good luck next week on the quiz, I guess.